Hey guys, welcome back to another episode of Math Unlocked. I'm your host, Mrs. Rhodes-Grierson. So I think you can see what we're doing today. So today we're looking at inequalities. Now, if you are new, I'm going to ask you to go first and check out what are equations and how to solve equations before you come here to this video and look at inequalities, right? So when we look at this statement, x is greater than 4. Now, the difference between an equation where I would have said, like if I had the statement x is equal to 4. In this statement, x have one single value. X is equal to 4. But in this statement that says x is greater than, it's not an equality because in this case, x doesn't have one value. It says x is greater than 4, which means that x could take on multiple values. So if we're looking at whole numbers only, and we say that x is greater than 4, therefore means that if x is it's an element of whole numbers only, we're looking at whole numbers. If I could say, or if x is an element of integers, so the z means integers, and integers means that the whole numbers can be either positive or negative. We're looking at both. So if x was an element of integers only, so we're not looking at decimals, and we said x is greater than 4, it therefore means that the values of x, numbers greater than 4 would have been 5, 6, 7, 8, and I think you get the gist by now, because those numbers go into infinity. So numbers greater than 4 are positive numbers such as 5, 6, 7, 8, on and on and on. These numbers mean it continues. These dot means it continues. So notice that if it's an inequality, it therefore means that the values, so there's not one single value of that unknown, but multiple values that could make the statement true. Notice I said make the statement true. So if x is greater than 4, x could be equal to 5. That would make the statement true because 5 is greater than 4. X could be 6. That would also make the statement true because 6 is greater than 4. Now, when we read our statement, when it comes down to inequalities, we must make sure that we understand what the statement is saying. So when you read a statement, you read it from left to right. And generally, that's how we read. But specifically now, you want to read the statement where the unknown or the variable is. So since the variable is here on my left, I'm going to read it to say x is greater than, so this is open. So x is greater than whatever value comes after. So x is greater than 4. Let's read this one. I'm reading from where y is. So what does this statement read as? Y is less than. Notice that the inequality sign is close to y. So y is less than or equal to, so this symbol here means or equal to 6. So what are the numbers, whole numbers or integers that would satisfy that statement? If y is less than or equal to 6, remember or equal to means the first y value that we're looking at is the number 6. Now, its statement says that y is less than or equal to, is not one value y can have. Y can have multiple values. Starting at 6, since it's less than, we're looking at numbers going down. So it means that y could be 5, y could be 4, y could be 3, y could be 2, y could be 1, y could be 0, y could be -1. When we look at this, and I'm going to put the dots now to state that it continues. So y being less than or equal to 6 could have all these values going into infinity, but this time the infinity is to the negative side. All these values would make that statement true. So it's not one value that makes the statement true. There are multiple values that could make that statement true. All right, so we continue. Look at this statement. This statement now has two inequality signs in the one statement. So how do I read that? Now, because I'm going to tell you about X, the statement is about X. I'm going to read the statement from X and tell you what are the values of X. Now, reading from X, here's X in the middle. So I'm going to read my left first and then I'm going to read my right. So what is X? Since X, this is open, so it's saying that X is greater than whatever comes after this sign. So X open, X is greater than -2. And if you know how the number line works, it says X is greater than -2. So greater than -2 would have been -1, then 0. Then we're going into the positive 1, 2, 3, going on into infinity, that direction. But let us look at the other condition of X. So X is greater than -2. Looking at integers only. Integers, these are your positive and your negative whole numbers. Looking at integers only. If X is greater than -2, then the first X value, it's not equal to -2, you know, this sign not there. So it's not equal to it, it's just greater than it. So it means therefore that X would start at -1. I'm writing the set of numbers that would satisfy this condition here. So X start right here. So if I'm looking at whole numbers or integers only, it would start there if I'm only looking at the whole numbers or integers only. So starting at -1, then all these values would satisfy it because they're greater than -2. But there's another condition on X to say X is less than or equal to 7. So I cannot pass the 7. So what are the values then? -1, 0, 1, 2, 3, 4, 5, 6. Do I write 7? It says X is less than or equal to. So 7 is also a value that X could take. Notice that this set now is not an infinite set because of the two limitations on X. X has a starting point and an ending point. Therefore, if I'm looking at this inequality statement, when I read it from X, I read the left and then I read the right. And I look at the both two limitations to say, what then could be the values of X based on that statement?